Of the more than 1,000 active or potentially active volcanoes worldwide, not all of them contain a highly symmetrical and towering peak. Yesterday's video discussed these types of volcanoes, while today's video will discuss the remaining 7 volcano types. Let's get started. When viscous lava erupts, it does not always form lava domes. In very rare cases, viscous lava cone volcano, typically of an andesite to dacite composition, can be associated with eruptions that have a low gas and volatile content, making them less explosive than a typical lava dome forming eruption. As a result, viscous lavas will repeatedly travel downslope, albeit not very far, and pile on top of one another to form a type of volcano known as a lava cone. The most catastrophic eruptions in the world often eject many cubic kilometers worth of lava, caldera volcano, either effusively or explosively. When this occurs, it can cause the underlying magma chamber at depth to drain, causing structural instability in the crust overlying it. This can then cause crust to collapse downwards to fill the pockets of air in the magma chamber, which forms a circular depression in the ground known as a caldera. These calderas are typically at least 2 kilometers across, but in some circumstances can form to be more than 100 kilometers across if thousands of cubic kilometers of magma was removed. If a volcanic eruption occurs underwater, submarine volcano, the pressure from said overlying water will impact how it occurs, generally making eruptions at deep submarine volcanoes less explosive. This is not similar the case, however, if a submarine eruption occurs at shallow depths, as it then becomes more explosive. However, the term submarine volcano simply applies to any volcano which has its highest point underwater. Subglacial volcano: when magma erupts into a thick ice sheet, it forms a subglacial volcano. During such an event, erupting magma initially forms a layer of material which looks much like a dome out of pillow lava. As eruptive activity continues, the heat melts significant volumes of overlying ice, creating a thick glacial lake in the volcano. After the glacial lake develops, eruptive activity shifts to a more explosive phase, depositing a rock type known as hyaloclastite. If this eruption occurred from a singular primary vent rather than a fissure and stopped at this point or a prior phase underneath a glacier, the resulting landform would be known as a subglacial mound. However, things change if the eruption continues. Over time, the erupting vent, which now has an unusually steep profile, breaches the surface of the lake, causing eruptive activity to change once again. Instead of being highly explosive, more effusive to moderately explosive eruptive activity occurs.